Okay, welcome to day 2 of the calculus notes on lesson 5.4. As I said yesterday, I would probably have my sum and difference formulas in hand and ready to go when it comes to this lesson. We also talked about some schools that you go to college to, they make you memorize these formulas. I will not do that since this is more of a general ed classroom. With people taking this that are non-engineers and non-math majors, as well as engineers and math majors. So let's take a look at example 5, proving a cofunction identity.
Just a reminder, please enter in your lunch counts. Please enter in your lunch counts.
So when you prove a cofunction identity, first off, if you recognize the expression on the left side with the cosine is going to be a difference formula with cosine. So we can make this our u. We can also make the x a v. So if we take a look at our cofunction identity here, I would go to cosine and take a look at the difference formula. In the difference formula, you're going to have a cosine u v, and I'm going to write that out. So the cosine uv would be this. It'd be cosine u, cosine v, and then it would be plus sine u, sine v. Okay, so our u is our pi over 2, and our v is our x. So I'm going to replace the u with the pi over 2. So I can go cosine pi over 2. It would be cosine x plus sine u, which is sine pi over 2, and our sine x. Now, both of these are equal to our sine x. Okay, so once we get that far, cosine pi over 2 and sine pi over 2 are both going to have a couple of values. So pi over 2, if you look at the x value in a unit circle, this cosine would be a 0. And of course, anything times 0 is going to result in a 0, which we will do in a second. The sine pi over 2 is a 1. So sine pi over 2, we have that 1, and then we will go ahead and we will simplify this. So 0 times cosine, that is going to cancel that off. And then just 1 times sine, well, that's just sine. So it'd be sine x equals sine x, and you just proved your identity. On example 6, we have a couple different things going on here. It says we are supposed to simplify these expressions. So first off, on letter A, yeah, I can recognize that. That again is the cosine difference formula. So I would go ahead, go to my formulas. I'm going to go ahead and write this out. So cosine theta minus 3 pi over 2, where my theta would be u, and the 3 pi over 2 would be my v. So cosine u would be cosine theta, cosine 3 pi over 2. It is a minus, or excuse me, it is a plus, and then the sine is uv as well. So we have a theta, then we have sine 3 pi over 2. Okay, so 3 pi over 2, if we go to that on our unit circle, for the cosine we would check our x again. So this one here is going to end up being 0, and that again would cancel off our left side. Sine theta is not going to change, but then we do have to check our 3 pi over 2, which would be negative 1. Okay, so again, our cosine on the left would cancel. We'd be left with negative sine theta. So you're essentially what you're simplifying this to, the original equation, would become just negative sine theta. That should be a minus. All right, so let's go to letter B. Okay, on letter B, we have tangent theta plus 3 pi. All right, and then I'm going to go to my tangent formulas. Now, we haven't used a tangent formula up until this point. So this would be a tangent sum formula. you follow the same process though. You name the theta u and you name the 3 pi v. So if I go ahead and go to the formula, I would put tangent theta plus my tangent b. Now my tangent b is going to be my 3 pi, which we can go ahead and plug a value in after this step. On the bottom we have 1 minus tangent theta and then tangent 3 pi. Okay, so from there, it's just a matter of simplifying what you can. Now, if you think about 3 pi is going to be around the unit circle 1 full time, and then 1 more pi. Because really, if you take pi plus 2 pi, you're going to get 3 pi. So I went around the unit circle 1 entire time, if you think about it, and then I would go right here, and I end up at pi on my unit circle with the repetition. So if we go ahead and replace tangent of 3 pi with a value, it would be y over x, and that's just going to be this formula right here. So that's something that we talked about right away. It would be 0 over -1, which is going to result in tangent 3 pi being 0. So in fact, I'm just going to go ahead and go to what I have written here, and I'm going to cross that one out, all right, because I know that's going to be 0. And then these two on the bottom, well, those two are going to cancel too. Because if I get tangent 3 pi, that's 0 times tangent theta, which would cancel it out. So really the minus would just be -0. So what you have left is just going to be a tangent theta over 1, which is just equal to a tangent theta. Okay, example 7. A little more complicated on this one. You're going to want to leave yourself some room. It tells you that the interval is between 0 and 2 pi, so you don't have to continue or account for the continuality of this. So I'm going to use both of these. I'm going to use the formula for sine sum formula. I'm also going to use the difference formula. So this one is a u, and that's a v, and then the same goes for the subtraction. Okay, so you're going to split it up basically the same way you've split up everything so far. So on the left side here, we have the sine sum formula. So we go sine u, which is x in this case, and then we have cosine b, which is pi over 4. Now keep in mind that's 45 degrees on your unit circle, which we will get in a second. So we have cosine x and sine pi over 4. So this is what I meant by you need to leave yourself some room. So again, you're going to have to do the same thing on the right and replace that with the difference one. So I have sine u, which is sine x. I'll try to write small here so we have enough room. All right, and then let's see, it's subtraction, cosine x, and then we have sine pi over 4. Okay, so really it's not a hard process. It's just a matter of you have to go ahead and you have to get this written out correctly. Okay, so when I get to that step, well, then I can start replacing the pi's over 4 with what they are equal to. So if I go to pi over 4, it looks like they are both equal to the square root of 2 over 2. So I'm going to go ahead and I'm going to do that. The other thing I want to do, if you look at it, would be to go ahead and check this one here and this one here. They are exactly the same thing. One is a subtraction sign, and then the other is positive. So I'm going to cross these ones out. I know they're going to cancel, which makes my life a lot easier. So if I replace my cosine with the square root of 2 over 2, and I can do the other one as well. So sine x is not going to go anywhere. I can replace this one here with square root of 2 over 2, and then that's still equal to our -1. Okay, so from there, I can go ahead and I can add these two together. Since they are the same term, I'm going to write 2 sine x, and then the square root of 2 over 2. Okay, So from here, since we do have a 2 out front and multiplication has commutative property, so I can cancel the 2 out, and then I have only a sine x and a square root of 2 remaining. Okay, so from here, I'm going to divide both sides by the square root of 2, which should give us a value to search for. Of course, that's not simplified. That is not what you would see on the unit circle. So we do have to simplify that, and that would become the square root of 2 over 2, and it would be negative. Okay, so let's go to your unit circle. We're looking for a y value that is negative square root of 2 over 2. So we find that at 5 pi over 4, and remember, you're only going to 2 pi, and then you're stopping. So the other one would then be at 7 pi over 4. So those would be your two answers. If you ever want to check this to figure this out, you could go back and you could plug that in. The other way to do this would be to go to your calculator, type that in, and you could actually trace the zeros on this. Of course, you're not going to find exact answers with the 5 pi over 4, but you will find the decimal version of this, and you will be able to check it by comparing them to what you found algebraically. Okay, example 8, which I believe is our last example here, is an application from calculus. So this is something that you're going to see again and again. You're going to use this for derivatives. It's basically the algebraic version. So, and we'll get to this with limits as we finish the course later on this year. Okay, so first up, if I want to go ahead and I want to prove this, I'm going to go ahead and I'm going to replace the sine x plus h with its sum formula. So I'm going to do that. I check my sum formula, and I would start writing it in. So this would be my u, that would be my v. So if I replace that, I get sine x, and you do want to leave some room again. This is going to be a rather large problem. So cosine h, we have a plus cosine x. We also have sine h, the minus sine x has not gone anywhere. So this is still all over h. Now, we have to look at that and we have to think, well, how do we make it look like the right side? So it looks like they did some splitting up of different fractions here. I also notice I have a sine x that maybe if I put these together, I could go ahead and I could factor that out. Since it looks like it's on the right side, I'm going to take the cosine x and I'm going to go ahead and I'm going to put that out front. So the cosine x sine h. And again, the reason I do that is because if you check out the right side, that is what they do. Okay? So, and then the next one I'm going to write is, I'm going to write the minus sine x, and then I'm going to write plus sine x cosine h. And then, of course, this is all over our h. Okay. So the reason I did that is, again, if you look at the top right, you can see that they subtracted. They also had a negative 1, or a positive 1, excuse me, in front of this. And to do that, you have to arrange accordingly. Okay, so first off, I'm now going to split the h, which you can do. It's almost like having 1 plus 2 all over 3, and then you split it into 1/3 and 2/3. Really, you're doing the same exact thing. You can split fractions if you want. So let's go ahead. Let's put the cosine x on this side here. Let's put that out front, and then I'm going to split the sine h and write that over just the h value on the bottom. Okay, so if you think about it, this here on the bottom left would be the same as what I had above it. The second thing I'm going to do is I'm going to go ahead, I'm going to take this sine out, I'm going to put it out front, and then what's going to be remaining is since I took the sign out of here and here, what I would have remaining, as long as you have the minus out front, would be a 1, and then this one, if I took a sign out, in fact, if I took a negative sign out, which I did, it would flip the sign. So minus cosine h, and then all over your h. And I do want to extend this parenthesis so that if people were to look at it, they would know that it would be over this entire quantity on the right. So that would be our match. Now we have everything we need to prove that this is the same as our right, or as the right side like we started out with. So that verifies the identity. So that concludes the second day of pre-calculus notes. I'll try to upload this to YouTube. I will also upload it to the Google Classroom, and then I will get you the assignment.